Am I live? I am live. Good morning, all. I think Oliver said I'd like to introduce everything. Those that know me quite well will probably know that I'd rather do the technical bits later. But I shall be here and give you a little introduction to the morning's events and what we'll see today. First of all, thanks to all of you coming along. It's a really practically a full house, which is delightful to see. And I hope you really enjoy the day. I'd just like to go through a little bit about the presentations and a bit about what I see are the current industry trends in optimization, our little bubble that is optimization, and then a little bit of an update on where we see GRM today before I'll hand over back to Oliver to kick off the proceedings. So this morning we've got quite a nice little spread, I think. We've got a nice insight from Marcus. No pressure, Marcus. Before we get change topic quite a bit to Rob Gow with mountain bikes, Dave Johnson in America's Cup, and then some additive manufacturing and into motor racing. I did realise, looking with the car there, two racing cars out there, and a lot of the theme, there's a lot of racing cars here today, and it's probably not just a reflection of what we're doing. We're doing, as you can see, all sorts of different topics and areas in engineering. I think it's more the fact that we really like racing cars, and they're quite fun to work on, exciting, and they're a good platform for developing a lot of the techniques and methods that we do. So this afternoon, again, it continues. A little sneak preview there, there's competition results, so there will be a competition I'll be taking you through this morning. You'll find it in your delegate pack. And then we've got some insights into what's happening over in Japan. We've got our colleagues from Harada Vehicle Design who've travelled all the way across today. And then some of our research activities. Before the last session, we'll be looking at composites, both optimization and manufacturing. And then the last presentation is one that I'm particularly looking forward to as well, because it really is a good example of what I consider to be optimized engineering design. So moving on to that, I've blatantly taken this slide from 2 years ago and just changed the 6 to an 8, because it took me ages to make that animation, so I thought I had to use it again. It's just too good. What is OED? We've taken it on now that that's the name of this event. And there's lots of different things you can think about it, but for me, my personal take on it is it's the bringing together of optimization into the engineering design process. Far too often, you see optimization sitting over here. I'll do optimization at the start, get an idea, and then I'll do an interpretation, and as all the other various factors, manufacturing, other design changes come in, it all gets forgotten, and we evolve, get to the end, and then at the end go, can we optimize the final result and get any little bits of weight out? Optimized engineering design for me is taking it on board right from the start, using it to then guide design, give some insights, to solve problems that have come out, new constraints, new challenges, new requirements come in. Can we use optimization to give us some insight into how we can solve those problems? And that's really how I see optimized engineering design. So, more chaps. In terms of trends, I'm not going to go too much into this, but there were some things that stood out when we were getting our plans together for the event. And we looked at what we were talking about 2 years ago, and what really has been happening. And one of the key things, very dramatic title to that slide, is we were talking in OED 2016 about a new tool, a new process that we thought was going to be quite interesting, which was topology optimization embedded in the CAD environment. So we'd fairly recently launched our product True from SW, which is adding topology into SolidWorks. Since then, it's kind of all gone a bit manic. We've now got a new technology. It's called generative design, which is the transformation of computational energy into creative exploration. These are quotes from Wikipedia and some of the major vendors. The automated algorithmic combination of goals and constraints to reveal solutions. That sounds very, very dramatic. It is topology. It's topology optimization, which I think most of us here have come across either in a great deal or to a lesser degree. But what's happened is in this 2-year period, it's been really quite dramatic how all the major CAD vendors have gone, we've got to have this. This has got to be here. So CATIA, NX, SolidWorks, Solid Edge, AutoCAD, they've all got it in some form, and they may have it with their own technology, or they've worked with partners such as ourselves or Vanderplatz. And now it's in the process, which I think is a really positive step. It's really bringing optimization that's no longer this sort of quiet, marginalized technology that's in the background, but is something that people are expecting to see. Can you do a topology on that? Or generative design. What is quite interesting and quite satisfying to know is that there's a little animation from 20 years ago of topology from Genesis being used in design. See, animations weren't quite as slick and renders weren't quite as slick back then. So it's not new technology, but it's really great that it's starting to be recognized and adopted. But for us, that's one very small piece in the puzzle of optimization and all the work we get involved in. And what's been very clear is that the demands for what people want for optimization are growing and growing in different directions and different expectations. One of the key things is more understanding, faster solutions, but also you see with what the CAD vendors are doing, improved compatibility. And that's not just putting it into the software tool that you're using, but allowing the data to be sent back and forth. There's real demands for getting that information back to designers, informing engineers of what results you're getting from optimization. And then I think Marcus may well make some mention of this, but it's the consideration of the bigger problem. Optimizers, I often go on to people about this when I'm talking about optimization. Optimization codes do exactly what they're told. You ask them to solve that one particular load case, they will. They have no human brain that goes, oh yeah, but actually, there's gravity happening and I should think about that. If you don't tell them, they won't consider it. So taking all that on board. And so, our role at GRM is to both develop the codes with ourselves and with our partners and educate the customers on how to get the best out of it. So just a quick look at GRM in 2018. I wouldn't say anything's dramatically changed in 2 years. We've continued to grow, and that's part of my ambition and all of our ambition in terms of how we develop is not to try and balloon into a huge company, but to keep ourselves as a solid team of people that people can work with and trust. But we've got our main sectors. It's always been software and consulting. That's how we see it. But we've started to recognize that there are particular skill sets and industry specialities that we're becoming very strong at. So we've got our software division, which remains sort of headed up with Vanderplat's Genesis and their other tools. And then we add to that with our Optisist and Trueform products. And then side by side with that, we've got Kaito, which is basically a name. I'll check this, Oliver. Composites, analysis, integration, testing, and optimization. So it's just bringing together what we know about composites. We've done it for quite a few years. So we've got the optimization software, the support of that, and the consulting with that. And then in the last few years, we've done quite a few crashworthiness projects, which is based on a lot of the research and validation we did in previous years. We started to now apply that on vehicle programs. Underpinning the consultancy side then is the FEA and the optimization, leading with everything. As you'll see today, we've also worked hard to try and bring up our skills in CFD, so flow simulation. And with that, there are a lot of companies that do CFD, and they do it probably a lot better than us. So our real core focus is bringing in with some of the new technologies, which is fluid structure interaction. So the flow simulation, how that loads the structure, how then the flow responds to your structures deforming and so on. So that's something that's quite exciting for us. And that leads back to the R&D side. So we've got R&D in our software development. We really are keen on Innovate UK projects. Having worked on a few of them now the last few years, if you can get a good collaborative team together, it works really, really well. If the partners work together, we get the knowledge of what we're doing with optimization, and then experts in the particular field. You'll see one later today where they know what they're doing, and we bring that together so we know what we're developing the optimization tools for. And then methods development, which you see with the FSI side of things. So how are we doing? We're good on time. Thank you. Oliver's got his 5-minute, 2-minute, and 0-minute time. Can we see the red one? I don't want to see that one today. The big red. If our presenters see that, it's like time, stop. Some really exciting news is we can happily announce the release of Genesis 17. Not technically on our servers yet. It'll be early next week that it gets put on, just some final testing from our side. Vanderplat's have launched it from their side. But there's several improvements across the board. I've actually got a big 4-page document of enhancements in the various parts. I won't go through that now. But just some highlights, really, in the various areas. Acoustic cavity modeling is in, something that I know there's been great interest for a while in that area. So that's in for coupling to the structures. And heat transfer analysis and optimization. Now, that's something that in the solver, was technically dropped in 16, but the environment around it's been improved, and now you can really work and do some nice, clever coupled optimizations for heat transfer calculation and structures together, and that's quite a sort of a important capability in many applications. Compatibility is key. We don't live in a world whereby it's only our tools. We've got to try and work together with all the other companies, partners, and so on. So there's been a lot of improvements to the data, so it can be directly working with other solvers. Composites. It's a nice example here. What we have is in user-defined topometry. This is very much something that stemmed from our consulting activities. So put under a lot of pressure to get some laminates developed very quickly, we realized that actually we've got our current workflow could occasionally have bottlenecks. So we've got now whereby a user can really put in great detail at the start how they want to think about making a composite structure before they go into optimization. So what they get out is ready to go almost immediately. And then interfacing with codes such as LSDyna. At the end here, we decided to use a rocket ship from something from the 1930s, I think, but quite nice. So you can also now, if you want to go for really quick studies, you can just simply take STL files and go straight to your optimization in literally about a minute. So now then, before I step down and hand over to the more interesting part of the day, I'd just like to introduce our optimization challenge. We did this last time with Swansea University. With ourselves this time, Van der Platz have prepared this example, and it's just going to give a little demonstration after lunch of their multi-purpose optimization tool, VisualDoc. And the key thing is a really simple problem. I thought it was a really simple problem. It kind of is, but what the answer is a bit of a challenge. So you should all have a little one-page sheet in your delegate pack explaining a bit more detail about this, but you've got a box and it needs to be a meter cubed. Simple as that. What is the optimal width, height, and depth to minimize the surface area of the cardboard being used? So, simple. What we'll do is if you have a go of that, put any answers on your paper and hand it in during the morning or by midway through lunchtime today, either to anybody at GRM at reception or just leave it here on the desk. We'll collate the answers and see who our winner is after lunch. And the prizes. So we've got a little winner's trophy. Nice to take away with us. Again, thanks to Van der Platz, a 6-month license of VisualDoc to have a play and see what you think of it. That's the glory of winning. That's what we want to do, really. We just want to win. And no GRM people can take part. Sorry, guys. So, because you probably have spied the answer. Yeah, you know the answer. You wrote it down. So, great. Okay. So with that, 2 minutes. Perfect. That's almost like a plan, that, isn't it? I shall now leave you to enjoy the day. Everybody have a great time. Do ask lots of questions. Eat coffee. No. Drink coffee and enjoy the day. Thank you.